So for this question, we have this transfer function 7 of 1 plus s over 860 times 1 plus s over 7900 in the numerator, and 1 plus s over 42 times 1 plus s over 123,000 in the denominator. And our first step will be to switch the s terms into j omegas. After we finish that step, we can then change our equation to the magnitude equation that will be used to make the Bode plot by doing 20 log base 10 of each term in the equation. In the transfer function, the terms in the numerator are referred to as simple zeros and will be positive when creating the magnitude equation. The terms in the denominator are known as simple poles and will be represented as negatives when creating the magnitude equation. After finding the magnitude equation, we can then find the phase equation by taking the inverse tangent of each term and using the same sign conventions as used in the magnitude equation. The terms, instead of being 1 plus j omega, will be the j omega portions of the terms by themselves. 7 will become a 0 in the phase equation. And then you then add the inverse tangent of j omega over 860. Then you add the inverse tangent of j omega over 7900. And then you subtract the inverse tangent of j omega over 42. And then you subtract the inverse tangent of j omega over 123,000. And that is your phase equation complete. You can now set up your plot to plot the magnitude equation by putting the magnitude on the y-axis measured in decibels and the radians per second, or omega, on the x-axis, ranging from about 10 to the negative 1 all the way up to 10 to the 7th. After you've set up your plot and are ready to start plotting each term of the equation, you can just choose a color to represent the constant of 20 log base 7, or no, 20 log base 10 of 7. This will be in blue. 20 log base 10 of 7 is 16.9, so you can represent it on the plot as a straight line across at that value throughout. You can then plot 20 log base 10 of 1 plus j omega over 860. This will be done in green. And this will be 0 until you reach the point on the x-axis of 860 radians per second, when it will then begin to increase at 20 decibels per decade. The next term we will plot is 20 log base 10 of 1 plus j omega over 7900. This will be done in orange. And to plot this term, it will be 0 along the x-axis until you reach the point of 7900 radians per second, and it will then increase by 20 decibels per decade. We'll then start plotting the poles of our initial transfer function as the term 20 log base 10 of 1 plus j omega over 42. It will be a constant 0 across the x-axis until you reach the point of 42 radians per second, at which it will decrease at 20 decibels per decade. The next term we'll plot is 20 log base 10 of 1 plus j omega over 123,000. And this will be done in light blue. To plot this term, you'll move along the x-axis at 0 until you reach the point of 123,000 radians per second, at which you will decrease by 20 decibels per decade. After you completed each term, you're now ready to compile your entire completed Bode plot. You'll do this by first starting at the constant value and moving across until you reach the radians per second of 42, and you'll then decrease by 20 decibels per decade up until the next change, which will be found at 860 radians per second. At this point, the negative 20 decibel per decade slope of the first term and the positive 20 decibel per decade slope of the second term cancel out, which gives you a constant slope of 0 across until you hit 7,900 radians per second, at which the plot will now begin to increase at a value of 20 decibels per decade until you hit 123,000 radians per second. At this point, the next term of negative 20 log 1 plus j omega over 123,000 contributes a slope of negative 20 decibels per decade, which cancels out with the previous term, giving you a constant line for the rest of your plot. Your final Bode plot should include labels of where the slope changes and should also include labels that indicate the slope value at specific points. In this case, the final plot was highlighted to ensure there was no confusion between the plot and the specific terms that were plotted as well. You can see by the plot that this is a notch filter, which will allow most signals to pass through except for those that fall within